I wanted to get the live stream going, so we get this video recorded. Anyway, I'm Roger Jackson. I'm on the board of the Rocky Mountain Inventors, along with Roberto. So we're just now entering our 41st year. This group started in '78. It's been a lot of versions since then. And so the overriding goal has just been to help people convert from a product to a business, because that's always the difficult transition, it seems. And so we run second and fourth Monday evenings here, all kinds of topics: funding, finance, prototyping, social media marketing, videos, basic entrepreneurship, bookkeeping, accounting, and whatever we request. We do joint meetings with the Denver Patent Office. They come usually a couple times a year and present, and then also with the Denver Public Library. The Central Branch has a federal research library, so you can go there and research patents on their system. They can give you training on searching and stuff like that. And so anything else you request will help with. So we're a nonprofit 501c3, so we just collect enough money to cover costs, basically, for website, email, and food and drink. So anyway, we'll go ahead and get started, and we do a round robin. Everyone take about a minute and introduce yourself. I guess I'll start with Dan real quick. He's the speaker.
Do you want to kind of bio? I'm Dan Kennedy.
Yeah, I guess you have plenty of time later. Okay.
I'm Dan's sister, Cynthia.
Okay. Good. And Richard?
Yeah, I'm Richard Hughes. I'm an attorney by day, inventor by night. You know what all that means, right?
Yeah.
Good, you?
Okay. Sweet.
My name is Sweet. I'm working on a game console stand for the Xbox One and PS4 game consoles. Just a new type of horizontal game console stand. And yeah, just kind of testing and prototyping right now.
Okay. Tom?
I'm Tom Stinson. First time in a meeting here. I'm from North Dakota. Just came out here one more.
All right. Warm up. Yeah, there you go. Brad?
Brad Strong. I'm a web and video guy by day and inventor by night. And I probably got, we're just talking probably about 30 inventions. And it's like a none of them become real. So it's just a monkey on my back.
I got that same monkey.
Okay, Roberto?
I'm Roberto Rusquena. I'm a patent agent. I've been practicing patent law for about 15 years. I registered with the USPTO, and I'm the US correspondent of a few Italian law firms. So I'm getting patent application from them. I do the filing and prosecution in the US.
Okay. Ed?
I'm Ed Wilson, and I've been in business for quite a few years and have a number of patents. Some of the patents that I got years ago, I ran out of inventory, and I'm having Dan make the parts for me.
Okay, great. And Rich?
Basically, I have a whole bunch of ideas that I've never seen to fruition. And, I don't know, I have one that I think my daughter and her sister can take somewhere and make some money out of. So that's why we're here.
Okay, you want to say anything, Adele?
Sure. I'm Adele. I'm his daughter. I'm here for the food.
Okay, again, I'm Roger Jackson, patent attorney. So if anyone has any ideas and you haven't already publicly disclosed, it's a good idea to keep them confidential. Still, I mean, in the United States, you can disclose for up to a year, but not internationally if you want international patents. So I guess I should say, what is disclosure? Well, it's the structural detail of how you're accomplishing a function. If you talk generically about the functional end result of your invention, that's fine, because there's a lot of ways to get to a single functional result. So anyway, I'll introduce the speaker, Dan Kenner. He was here in early 15, so it's been a little while. But Dan owns and runs a machine shop, Accudyne. So I asked him, just two things. He's going to talk about, what machine shops want and look for, the amount of detail, what to expect for timing and cost. And also he has some inventions of his own. He's going to talk about launching those, licensing, and so on.
Yeah.
So turn it over to Dan. Thanks.
Well, my name is Dan Kenner. I own a machine shop called Accudyne Corporation, and I own a marketing company called Accudyne Products. The machine shop is what we call a job shop machine shop. And what that means is we competitively bid on jobs that people bring in to us they have drawings, they have specifications, they have different materials that they need parts made out of, and they're looking for input from us many times, not all of them, many times, looking for input from us on how to best make their part. Not that I didn't know anything more than any other machinist, but it happens on a regular basis. So we like to work with companies that are flexible, that are open to suggestions, to engineering ideas, manufacturing practices that improve the way their parts can be made. So Roger invited me down here to talk about what we are looking for as a machine shop from people that have products that want to develop, products that they have already developed to get to market. And so basically I'm going to go over some of my experiences that I've had with inventors, some of the mistakes I've made with my own inventions, and some of the successes I've had, and some of the products that came out of these inventions. Because when you invent something, it's like an evolution. We start with one thing and we end up with something else. And it seems to always work that way. We start with something big and we end up with something 5 or 10 times smaller than what we started out with, or sometimes bigger. We started out with a bar puller this size. We ended up with one this big. Now we're making them twice as big. I just didn't want to carry it. So it's interesting the way that happens. I invented a setup gauge for a milling machine one time. It started out this large. It was 35 pounds. It wasn't the easiest thing in the world to make. It held a flatness of 1 micron over 16 inches and parallelism of 10 microns over the same 16 inches. That was something I did at night. I was a machinist by day and an inventor by night. And so that product, an interesting side story on that product, and Roger was talking about patent searches. I developed that product in 1993, back before the internet really took off, and I did my own patent search down at the Denver Public Library. And I searched around for products that were similar to that tool. It was a gauge for squaring a spindle on a milling machine. If anybody knows about a milling machine, you know that spindle needs to be perpendicular to the table. So I developed this product. I made a couple of prototypes. I showed it around to people around town. Everybody liked it, and they said they would buy one at X amount of price or at X price. And so I did a patent search. Didn't find anything that was even remotely close, and so I filed for a patent. I developed a product. I started selling them locally. I wrote an article and a press release, sent them into some trade magazines, and I published them. And then I started selling the tool. A lot of them. And about a month after that, that initial press release got published, I got a call from a guy in Sterling Heights, Michigan. His name was Tom Nook. He says, "That's a nice product you have there, son." "Well, thank you. Would you like to buy one?" He said, "Actually, no, I have a patent on it." And I'm like, oh my God. So the air went out of my balloon. I just, I was devastated. But he was a good guy. We worked out a licensing agreement, and basically I paid him a royalty for the time, all the time that the product was in, that we sold the product. So that was my experience with patent searches. I would recommend anybody that's going to spend a lot of time and money developing a product, make sure that it's not already out there. Just because you can't find it on the market doesn't mean somebody doesn't have a patent. Yes, sir.
So what would you have done if you go back in time? Would you have gone to a patent attorney and say, help me search this
I
out?
would have, exactly, I would have gone to a patent attorney. Back then, I believe they would to send all of their requests to Washington DC. I'm not an expert on that, but that's my guess. Now, Google Patents, and I'm not making any recommendations here at all, but the resources you have nowadays are phenomenal. But back then, looking back, that was a learning experience for me, and I was talking to Roger just the other day about patent searching. And even though with Google and all the other things you can find online, that's not what I do for a living. I don't chase those kind of things down. Roberto and Roger and this man in the back, maybe they do, I don't know. But it's something that I trust myself on, something that I'm going to spend thousands of dollars developing and laying down the market and so many things like that. I just wouldn't do it without a search. So, yes, sir.
So on that, were you waiting for the patent to get finalized then before you? You filed a patent for it, correct?
I did.
You did. So did your patent not get rejected, or?
No, I think it just went by the wayside. I didn't pursue it. We sent in a patent application. I got a call from the guy, and he gave me his patent number, and I found it, and it was like, oh my God.
Oh, okay, so your patent is still pending.
It was.
Oh, okay.
Yeah, it was. Yeah. But it became abandoned very quickly.
Yeah.
So, anyhow. So that was my experience that was my first experience with filing for a patent. And anyhow, so I've been in this business since, all my adult life. I started in 1969 in metal shop class in high school, and I've been fascinated with it ever since. I love working with metal. Nowadays, we're working with all the exotics and plastics and all kinds of things. And I just love it. I love figuring out how to make things. That's if I had my ideal job, it wouldn't be running a business, it would be building things. I'm a business owner by day and an inventor by night. I've heard that 2 or 3 times in there. When you have a business that you have to keep track of and things like that, finding the time to tinker is not the easiest thing in the world to do. For me, it's this particular product. I'll talk a little bit about this, and then we can move on to the main thing that that Roger wanted me to talk about. And that's basically what we're looking for from inventors, people that are trying to develop a product and a product line. Basically, this is called a bar puller, and what it does is it's inside, it gets mounted inside a CNC lathe, a computerized lathe, and when a part gets completely made, or just about completely made, they cut it off. The machine cuts off the part, it's caught in a basket, it's called a parts catcher, and then there's a couple of ways of advancing the bar that's inside the spindle. One is with a bar feeder. It pushes the bar from the back of the machine, and another way is with a bar puller, which pulls the bar from the inside of the machine. Basically, it goes over the material, the bar, and pulls it to a specified length. Then the chuck clamps down on the bar. The bar puller comes out of the way, and you make a part. The problem with the bar feeder is they take up a lot of room, and they're relatively expensive. They start out about $10,000 and go up from that. They go up to $50,000, $70,000. This tool here is $600. But the unique thing about this is that it needs no adjustment. It's a total hands-off. Once you mount this, once you calibrate it, it's just a matter of changing a number in the program to go from one bar size to another. And this was what got me going on this particular product. I had one of these, actually one similar to this, mounted inside my machine. We were going from one bar size to another. And it was a matter of taking everything loose, resetting everything, bringing the tool down on the material, checking it out, making sure it was going to work, and then fine tuning it. It was about a 15-minute process. And it just drove me nuts. And I said, there's got to be a better way. So basically, I identified a problem, which probably everybody in here has done, is identified a problem. And I went about finding a solution. So what I wanted was a tool that would go from one size to another size without having to do anything manual, without having to make any adjustments on the tool. And what we ended up with is a tool that I can show you how this works. And basically what we're going to see is a little video. It'll be about 30 seconds long, that will go from 1/8 of an inch to 1 1/8 inches in 7 different steps in about 20 seconds. So Raj, can you start that?
Oh, sure.
Or I can start it, I guess. So what you'll see, hang on just a second. Pause it.
Is that all you needed?
So what you'll see is this tool going down over the bar, pulling it out just a little bit. Now it's going to a larger size, and even larger size. And that's all we need.
How's it doing
Well, you can pause it now if you want. We can watch the whole thing, it's only a few minutes long if you want to.
Yes, sir.
Okay. And then that'll explain how how it functions.
These are friction-loaded hardened steel grippers that have a low bar design. This is a part of the tool that actually holds onto the bar. As you can see, these grippers provide very strong force for holding the material. The force is generated with the urethane spring backed up by hardened steel lifters. The lifter is actuated by a cam action provided by these hardened steel arms. I have removed the top cover of the tool to show the urethane spring and the lifter. As you can see, these springs are very tough. They are 95 A durometer. They're much stronger than die springs of the same size. They don't gall, they don't shatter, and they don't wear out. All components fit neatly inside the body and are protected from chips, debris, and coolant. We have seen what the Easy Puller can do with round stock. Now let's see what it can do with hex and square stock.
So this is one of the side benefits. This thing will pull hex stock and square stock as well. Something that none of the other markers will do. So we'll pull around, and then square. You can see that, and then hide the tool.
You just saw this tool pull an 1 3/8 hex, 1/4 inch round, then a 1 inch square, all without adjusting the tool. The only thing to change was the X value at the end of the first rapid move. This X value can be changed in seconds. Think of what this means on short run jobs. The Easy Puller is always on center, never needs adjustment, and is ideal for runs of 10 parts, 50 parts, or 50,000 parts.
So that was the video. And basically we drive people to the video through Google Ads and advertising and trade magazines. we identify the trade magazines that get the most hits, and we stick with those guys, basically doing marketing. I would do something when someone comes to buy a product to find out how they found out about it. Ask them, identify, where did you see it? And you know, some people will even go to the extent of offering them a discount if they tell them how they found their product. That will allow you to home in on whatever is working. When we went from a very poorly written and designed quarter-page, full-color ad in a very high-priced magazine to a very well-done, full-page, four-color ad in a lower-priced magazine, our sales went tremendously higher, went a lot higher. We ran, I was telling you, Ed, we ran a short blurb on a Google ad that basically asked the question, do you need a better bar puller? And anybody that's used one of these absolutely needs a better bar puller because they work, but they're a pain in the butt to get them to work properly. So people see that little thing when they're searching on the internet and they click on it and it costs whatever it costs, you know. But they see this video and see what the tool can do, and it just, our sales have gone way up since we started with Google Ads. And the success to that Google ad, I think, was the question that we posed, do you need a better bar puller? Because it was a problem that I identified when I was working on this thing so many times in my own shop. And it was, you know, it was just a very difficult thing to do, to make parts, so.
Did Google Ads help you design the ad, or did you have to do all that yourself?
Yes, they're very helpful. It wasn't really much of an ad. They'll walk you through the process. But as far as the ad itself, it's just one line. It's a headline, it's a meta tag, and a few other little keywords that are underneath there. Bar puller, self-adjusting, and a few other little, I don't have that, you can probably find it on Google real quick. But yeah, the people at Google are real helpful. And it's a simple thing to do. I mean, we were up that day running our sales change that week.
And the one you had, the prototype you showed us, that was where you had to undo stuff and readjust in 15 minutes. That's something you made yourself or something you bought?
This was a purchased product.
Okay.
This is $1,200.
And so yours is?
This one is $595.
So it's half the price of the really painted butt one.
Right. Yeah.
Wow.
So it was identified the problem, I found a solution. This took about 3 months before I got to the point where I was able to present it to somebody. But that was, you know, that was working at night, you know, and weekends. I kind of knew what I wanted to do. I knew that I wanted something that would go like this, but still have the force. And I just got real lucky, and it worked out. I mean, you saw that I was able to pull square stock. That's unheard of. There's an M code that not all CNC lathes have. It's an M19, which orients the spindle. That's how these people pull square stock. But not all lathes have an M19 function. And it's just, you know, it's more code that you have to write to make it work. So, like I said, we just got real lucky.
Well, let me ask you this too. Does yours run off a machine code or anything? Or is it just physical? Your product, the way it grabs the square stock or whatever. Is it physical only, or is it something you're programming into the machine?
No, it's totally, well, it's physical for sure. Yeah. But you control the distance on the X that the tool goes. It's a, let me just pass one of these around. I put some really soft springs in this one. I've got a 60 Duralyte spring in this one, and an 85 in this one, or an 80 in this one. You can feel the difference. These are 95 Duralyte. You can't move these. So you can see the difference. So to answer your question, it is physical. But that's, if you want to just try and open that, the one on this side is very easy. That's a 60 durometer. And the one on the other side is, I'm thinking it's an 80. These are 95 durometer springs in here.
Did you
And-
use those on the porch you made for me?
Probably not. Probably not. Yours
You had
were,
the aluminum stock that you were.
yeah, no, that was too big for our machines. Yeah, and that we just sawed up. We just sawed it up and then squared it up on the mill and then cut those chamfers on and put the holes in it. And you're off. I love your product, Ed. That was, those were very nice tools. So just to give you an idea of the difference in the springs. That's a 95, that's a 60. And the only reason we went to a 60 was we got a call from a company out in Salt Lake called SKF Bearings. And they make Teflon bushings. And they wanted to be able to pull them. Let me get up here. So you see how that works?
I believe so. It doesn't actuate per se, it just goes down on it.
And it pushes those arms
Pushes
out.
those arms out,
Pushes
and
those
then it
arms
increments
out.
so far, and then when it pulls,
Then it retracts, right?
pulls the tool off, so there is no mechanical advantage with these opening and closing per se, they just force themselves on the
It's
piece
a
of
matter
our
of
stuff,
force
move it,
and,
and then pull themselves off.
Right.
Okay.
Yeah.
Initially, I was very confused by that, but now I understand. It's just a little cam and lifter.
How accurate is the pull out? Is it 10,000?
Pardon me?
How accurate does it pull out?
it'll repeat within 2,000,
Oh,
which is, 25.05 millimeters, something like that.
That's about
Yes.
So anyhow, that was a product that I had a lot of luck with, and we're selling them all over the world now. All over Europe, all over, the only place we're not selling them is in Asia.
Because they're stealing,
Pardon me?
because they're stealing.
They may, maybe, I don't know. But Australia, Africa, Middle East, Canada, a lot in Canada and Mexico. So,
and this is a standard interface for
that's how it's mounted, it's a mounting bar.
Okay.
That's how it's mounted in.
Well, so you guys doing those in-house, or are you sending those out somewhere?
Pardon me?
You guys building these in-house?
We build in-house, yeah. We have farmed out certain parts of the product because we were so backed up, or our sales went up 1 month. I've had people order 20 of them at a time. And it's like, gosh, we've only got 2 weeks of supply left, and it's, what do? You scramble. So,
Good problem.
pardon me? It's a good problem. So, that was my experience with that tool. Anyhow, I'm working on another mounting system. This thing does have a drawback. If you mount it in your machine, a lot of machines have a wedge lock mount. In other words, there's a bolt that pulls a wedge against the side of the mounting bar and holds onto it that way. The problem that this tool has, this is our tool, is that the body of the tool covers up the outboard bolt. So they have to put this out even further. That causes an interference problem inside the machine. And I was talking to you the other day about a patent search. That's what our mounting system is what I'm gonna what I want to do the patent search on. So anyhow, so what I'm looking for from people that are developing their own products, basically, if you have engineered prints if you have a very clear definition of what types of materials you want, fits and tolerances. In other words, if you have running fits, if you have interference fits, if you are building something that has a sliding motion, you have clearance, the strengths of materials. Do you know what kind of materials you're going to need? Do you know which ones work best for your application? Do you know which ones are the most cost effective for what you're trying to build? These are all kind of things that I can tell you what's more expensive than something else. I can give you an idea of the different costs of materials, the different costs of machining those materials, and the tolerances that you need to hold. And it's a big formula. There's quantity, there's tolerances, which we just talked about. There is the different types of materials. There's finishes after, there's heat treating, there's all kinds of things that go into an equation. And delivery is a big thing too. If you've got something that you've got a month on and it's going to take 2 or 3 hours to build, that helps. If you've got something you need tomorrow and there's 40 hours worth of work, we got a problem. So, and it will affect the price. So those are some of the things you need to think about. Yes, sir.
Do you prototype only metal?
No. We work with plastics. We try to stay away from wood and wood products. I don't know what other substrates. We don't do much work with glass, although I have worked with optics. All the different types of metal, cast iron, carbon steel, alloy steels, titanium, aluminum, obviously, and all the different types of plastics, and plastics run the gamut. They've got some really sweet plastics now that are very, very strong. Some are easier to machine than others. Some have different applications that, you can't do anything else. They have insulating qualities. They have thermal qualities. They have all different kinds of qualities that'll affect the performance of whatever you're trying to build. They have glass impregnated plastic, which is difficult to machine, but it's very, very strong. I've seen that application used in handguns. Some plastics are very malleable. They're less expensive. Some will hold up better and when they're submerged in different liquids. Urethane is kind of a cross between a plastic and a rubber, but it's a perfect application for what we're doing. And if we were to use, I couldn't build this with steel springs. I could build it, but it wouldn't perform the way it does. So I really had no idea that they were using urethane as a spring. They use them as die springs. And they're much stronger than steel. They don't shatter. They're quiet. They've just got a lot of advantages over steel. Steel has some other advantages that plastic that urethane can't quite come up to, but people have their preferences. So some of the mystery. One thing that I worked with many inventors. Ed's a very successful inventor. Rich Chisholm has some great ideas that I would imagine he's still working on. I've worked with some people in oil and gas. I've worked with people in telecom optics, fiber optics. I had one particular product that a guy came to me with that he had a patent on, and I built some prototypes for him. I actually built quite a few prototypes for him. We got the design figured out, and there was some installation issues. Basically, it was an internal vapor recovery unit for an oil and gas separator. So it's a big long-winded name for a part that's about that big around and has the moving parts. So great product, one of the top 4 oil and gas producers in the world had 12 of them installed in their oil field up in Wyoming, and got great success. They came back and started negotiating another purchase for 24 more of these things, and they were not cheap either. Those were $1,200 a piece. It cost about $150 to manufacture. And the inventor just kind of closed up and put his arms around the product and just kind of went back in a hole and just kind of put a bad taste in everybody's mouth. And the product still has a patent. It's got about 4 more years on it, and it's just a really sad story. And that's what I would call, for me, it was a bad experience. It was a learning experience for me, but it was something that was just out of my control as far as marketing goes. And it was just a sad thing, because it could have been a multi-million-dollar product. It was saving the oil and gas company thousands of dollars a day.
What's the inventor's problem?
What was his problem? He was very secret. Even though he had a patent on it, he was very, very secretive. He didn't trust anybody, and every place he went, the door got slammed in his face after that initial experience with that oil company. And it was, like I said, it was a sad thing to watch, because it was a very good product. And I don't know if anybody here can relate to that, but it's, that was something else. I invented another product that I didn't get a patent on. I got a call from a fellow out in California that I met at a trade show. I had a booth at a trade show, and this guy was 2 booths down. We kind of started talking, we hit it off. This was that product that I was telling you, that Gates that I put, you've seen this tool, the Easy Trim. It's a gauge used for squaring spindle on a Bridgeport mill. So I was at a trade show in Los Angeles at Westech, and I was talking to this guy, we hit it off, and he gave me a call a couple of weeks after the trade show and asked me if I could work on a product for him and see if I could solve a problem that he had. So I went to tinkering in my little shop there, and next thing you know, I had this product that I came up with. I sent it out to him, and he said, very nice, let's see what we can do with it. He spent probably a month and a half trying to market it, and said, Dan, it's a great product, I just don't have the time to mess with it. So I ran a product release in like 4 trade magazines. And I got a call from a company out to the East Coast, and he said, we bought one of your tools, we like it, we want to talk to you about whether or not you would license this tool to us so that we can manufacture, market, carry inventory, sell it all around the world, and so we went into talks. I didn't have a patent on it, and I talked to the owner of the company. He said, you know what, you can spend X amount of dollars getting a patent. And in retrospect, I was a little naive at the time, but I got real lucky. I was working with a company that was very reputable. I called some of the other people that they were working with, because they had other products that they had worked out deals with, and they licensed the product. I don't know if you would call it licensing without a patent. I don't know. Would that be a license, or would that?
You can. Part of it's a trade secret.
Yeah, we have a written agreement, basically, and I'm still getting royalties.
Yeah, I mean, it's been done.
Yeah.
It's just, it's difficult though.
Yeah.
Well, isn't it possible though that someone else could file that patent now? Because then they.
No, because it's already, number 1, it's public domain. Number 2, you could show they probably derived it from you. So then they have to sign a declaration that says, I invented it. So they'd be lying that they invented it. So there'd be a lot of reasons they couldn't do it. I mean, an outsider couldn't do a future patent.
So anyhow, that's another instance where I got very lucky. I got hooked up with a company that was very reputable and very honest, and you know, there's, to this day, they're still paying a royalty every 3 months. And it's not enough to live on, but it's enough to, you know, pay some bills. So that's my experience. One thing that a lot of inventors do is they don't clearly define a market sometimes, or they don't know exactly what their end goal is, what their end game is. And one thing that I've found is that if you've got a product that you would like to bring to market, have an idea of where you're going to go with it. I don't want to talk anything about who you should talk to. I mean, Roger or Roberto, probably better off talking to them. I mean, not probably, but very much better off talking to them about what you would do with your product. My instance is I've got people that I know that can use what I built. So before I spend a lot of time and money doing anything, I run the ideas past them. I particularly don't get an NDA because I know these people, and I've worked with them for many years. They're a close-knit inner circle of friends that I have developed from being in business over the years that I totally trust. So I don't have a problem at all showing them what I have in mind when I'm getting ready to build. I give them a rough idea of the price that I think I can retail the product for, and then I get their feedback. So basically, it's a matter of figuring out, identifying the problem, figuring out the solution, making sure the benefits are going to outweigh the cost, and then you know, get it out in the world, let people see it and get feedback from them and see what they would pay for. You know, so whether or not they would use it. And those are the things that I know as far as bringing products to market. And as far as working with inventors, you know, that's one of the things that the guy that I was talking about with that oil and gas, that vapor recovery unit. I would say that if he had trusted, if he had maybe a business manager, I don't know, who would that be? That would develop a product, that would get it to market, that would do all of that stuff. Shark Tank maybe, or?
Yeah, I mean, you need a team of people with, you know, special skills and contacts.
So, anyhow, that's special skills and contacts, I would say, is a big thing on a deal like that, you know. And on a product like he had, I would imagine that even though he did have a patent, I don't know how thorough it was or how all-encompassing it was as far as whether or not somebody could make a few minor changes, but I'm sure that's something that the patent attorney would talk about. Is there anything else? Yes.
I have some drawings done for a couple of my products by a guy from Pakistan.
Okay.
For like nothing. But I have taken those to a prototyper. Mm-hmm. They go, great, that's what we need, because it's got the specifications,
sure,
measurements and drawings and things rotating 360.
Mm-hmm.
Have you ever had any experience with some of these outfits or people from the other side of the world?
Offshore?
Yeah, not just doing drawings and specs and so forth.
I haven't. I get emails from time to time from people that just by the way their emails are written, you can tell they're offshore, or they advertise that they're offshore. I haven't experienced anybody that's had products drawn up overseas.
But are you in the business of making products once they've been designed and ready to go and everything? I mean, make thousands of widgets a day?
That's our bread and butter.
Okay.
Yes, sir. That, the question
How
is,
do you compete with offshore companies that proclaim to do things so much cheaper? Let's just say China. How do you deal with that type of competition?
well, we develop a relationship with our customers. And we pretty much guarantee that we can do what we say we can do. And if we get in over our heads, we let them know right away that we're in over our heads. But as far as overseas competition, we've got a couple of advantages. Number one is delivery time. Number two, if there are any issues with a product, we can generally straighten it out in a matter of days, if not 1 or 2 days. I have seen many, many people go overseas to China, to Vietnam, to whatever place that can get labor for very little money. Only to get their first delivery of product 6 months late, and then it doesn't work. And then they come back to me and say, Dan, can you make these things for 50 cents and have them for me tomorrow? Like, well, no, it's more like $50 a piece, and I can't do it for another 2 months. So I try to stick with my original quote. I actually don't try to compete with those people. But we are competitive. We are competitive. Except for when you get in, it's all about quantity and complexity. If the part is very complex, and if there's 1 or 2 pieces, or 10 or 20 or 50 or 100 or 1,000, we'll bid a job, and the customer is always weighing past performance, reputation. There's a close-knit society of machine shops in Denver. And not everybody knows everybody else, but they know somebody that knows someone. So some shops have a reputation for working on prototypes. Some shops have a reputation for running medium run production. Some shops work exclusively with castings. Some work exclusively with molded products. So there are a lot of specialty shops around town, and typically we're much more nimble, I would say, than most overseas job shops. If you're getting 50,000 steering wheels made, I would say China's probably the place to go. If you've got the time to develop a relationship with a manufacturing company overseas, and it's the difference in price is $50 as compared to $3. So it would be worthwhile for somebody that's looking for those kind of quantities, that kind of complexity, and those prices. But it's something you're going to have a long lead time and a big long learning curve too. So I'm not saying they can't do it. In fact, they do a lot of things very well. Well, you know, oh, go ahead.
I've heard stories of people having a bad deal, China or Taiwan or whatever, and it puts them out of business. One bad order where the parts don't work. That's
absolutely.
It. A small timer can't take much more than that.
Yeah, it can be uncharted waters for a lot of people, and it's something that they can go into a situation like that with their eyes wide open. And it's just like me checking out that one company that I worked with that was interested in that one invention that I came up with that I didn't patent. I asked people that worked with the company, and every last one of them that I talked to had nothing but great things to say about it. And I would imagine if somebody is going to take a product to China, they would do all of their due diligence, do the background, ask around, find out, find some customers here in the States that they've worked with, and the world's changing. It's getting smaller, but we still have the advantage over these cheaper manufacturers to a certain degree. And I think prices over in China are gonna be going up. I really believe that, you know, they're going through some changes themselves, so. So to answer your question, the biggest advantage we have is being flexible, being nimble, being able to solve problems quickly and fix.
And you speak English.
And speak English, yeah, communication is a big deal, obviously. But they have people over there that speak English as well. A lot of machine shop owners have retired here, gone over there and started their own machine shops, or gonna work for large manufacturing companies to run the plant. Or to be in sales. So
I got a question. So if someone's, like, let's say they started producing their product with you guys or another like local machine shop, do you find that if that product grows to a demand where you can't meet it, is the departure or like them, you know, being like, okay, well, we have to, you know, go to China to manufacture because we need to produce more? Is that usually an issue, or? Because I mean, I'm like, you know, like you said, you know, if you're wanting like 50,000, like let's say they start out with you and they only need 1,000, maybe 5,000, and then demand picks up, and eventually they get to, okay, well now I'm 50,000. Like, I mean, is that something that you work with them and now you're going to produce 50,000, or is it like, okay, well, you know, your kind of demand is higher than what we can really do, you know?
generally what I do, when a customer comes in with an order larger than I can handle, I try to recommend people locally that I know. And that happens quite a bit. We have companies that our largest company is actually a growing company. It's growing, and their orders that they send us are getting larger all the time. So where they were placing orders for 200 parts every 3 months, they're now doing 500 parts every 3 months. And then down the road, it'll be 5,000 parts. And some of their products have a lifespan. You know, they'll ramp up and they'll kind of level off a little bit, and then they'll come up with a new product that's better than that one, and that one dies down. So it's constantly changing. And I've only had one company pull a job and go to China. And that was the situation that was very similar to what I was talking about, where we had been making parts for $50. The quantity went up. They went to China. They wanted, I don't know how much they were getting their parts for, but they didn't really get the parts. They didn't get good parts. If somebody wants to do that, that's their business. You know, I can tell them what my experience has been with customers that have done it. I have one customer that did that. But, you know, I know what my limitations are. I know where I'm comfortable, and, you know, there are shops around that can blow the doors off of what we do, because they're geared up to do the 20, 30,000 part production. That's not something we are really interested in. However,
I mean, that was kind of my, you know, curiosity is like, you know, is that, you know, sending that client to another manufacturer, is that an issue? Because I've heard issues of, you know, someone starts working with a manufacturer, they get tooling with that manufacturer isn't delivering it, they want their tooling, and then it becomes like a legal issue of like trying to get their tooling, or, you know, trying to go to another manufacturer. So.
Well, generally,
but I mean, it sounds like you guys all have an understanding around here.
Pardon me?
It sounds like a lot of the manufacturers here have an understanding with each other that, you know, like if we can't handle it, we'll work with it too.
Well, let me see if I understand what you're asking. If someone has, let's say, like mold that they pay for, that belongs to the customer.
Yeah, exactly.
So they can take that mold to any mold shop and have parts made, even if it's overseas. But nowadays, what they're doing is they're making the molds overseas and they're bringing the mold back here, and they're making the molded product here. I don't know if I'm answering.
Yeah, I mean, it does.
Yeah, so, yeah, if somebody comes in with a, if we bid a job and we get it, and the customer says, okay, we're gonna cut you a purchase order for X, Y, and Z jobs. We need these parts made in 6 weeks. You'll get paid 30 days after they're done. Here's our credit references, we establish, all the ground rules and everything goes into place. If we start running that job and we get to a point where we identify the job's gonna be late, we call the customer, they have the option of pulling the job because we can't meet their, what they're looking for. Or they can, sometimes they'll cut a PO that has, penalty clauses in it. So that if you're late, or if the parts don't perform, or whatever it is, you can get fined, basically. And you find out a lot with government contracts. Did that answer your question?
Yeah.
Okay. Anybody else? Roger, was there anything you wanted me to talk about?
I guess, well, you said you're a job shop. I mean, like when I was at Sunstrand, we were probably considered a job shop too. Like you do more specialty, lower volume, type, or initial smaller production runs. So maybe you do volumes up into the hundreds, but not into the thousands.
We do thousands, yeah.
Like you do 1,000.
Typical order for our largest customer is 2,500 parts. But what they do is they'll cut us a blanket purchase order with a 1-year duration. And they'll guarantee that they will take good products, and again, releases of 120 a month or 120 a week, whatever the number is.
Obviously, you spread it out.
They spread it out, and that's a big advantage for them. They don't have to carry inventory. It's an advantage for us in that we can run 1,500 or 2,000 parts as opposed to running 120 a month, or whatever the number works out to, 200 a month, whatever it is.
Yeah, given like the machine setup.
Yeah, right, yeah, so we set up and we run the whole thing out. But we're carrying inventory, we're carrying, labor and everything else. And then they have the option to take whatever they want when they want it. Yes?
How many mills and lathes and 3D printers do you have?
I have 4 CNC mills, I have 5 CNC lathes, I have 2 programmable vertical mills that are conversational programming. I have 2 conversational programming lathes. I have all the standard manual equipment, surface grinder. I have a 52-inch lapping machine. I have welders. I have a couple of manual lathes, and no 3D printers.
So that was my next question, is that the way 3D printing is exploding, is that affecting you guys at all?
Not yet. A lot of, I'm not that familiar with 3D printing. I understand the concept. One of the things that we compete with them on is engineered plastics. So my understanding of engineered plastics is that it's either extruded or extruded or roll plate, extruded bar stock. Its mechanical characteristics are much stronger, I think, this is my understanding, than 3D printed plastics. Now, I could be wrong on that. I don't know enough about it, but I know that our customer, the one customer that uses a lot of plastic parts in their product, haven't gone to 3D printing other than prototype. So
I think
the advantage 3D printing has, there's a couple of advantages that they have. You can make parts overnight while you're sleeping.
I have an argument right now.
But it is pretty slow though on a per part
It is,
basis.
yeah, it's fairly slow.
Yeah.
It's actually very slow.
Yeah.
But they can make parts that we can't make. They can make a part with a hollow square cube inside it, you know, we can't do that. I mean, we could, but it would be ridiculously expensive. So yeah, it's a slower process. I'm sure they're working on speeding that stuff up all the time. But, you know, they're 3D printing houses now. It blew me away, and I said, wow, this is pooping out concrete, you know, and it's going around and it's doing its deal, so. Yeah, I really don't, it's not my, it's not something that I'm really wanting to get into, is 3D printing. People do that. That's great, you know, more power to them. I cheer them on. One of my good friends has a shop called Quality Components, Vern McElroy, and he's got 2 3D printers. So, you know, they're professional. They're not your little benchtop, they're big machines, and that's what a lot of what he does. He's also a chop shop, machine shop. But yeah, the 3D printing is great for people that want to make a product and see if it works, show it around, make sure things are going to work out, prove their design, and get something relatively quick. You
I
know,
always thought it would be appealing to you guys for making jigs and fixtures like on the fly to get work done faster.
yeah.
You know.
Well, you know, there's 3D printing metals now, and I don't, to get up and running on a job, typically we've got, when we make a part, if we know that it's going to come back, we'll have setup sheets, we'll have process sheets, we'll have stuff stored in our in software that tells us how the part's made, what the runtime is, where the tools go, pretty much anything from point A to point C on that whole job. And we have a job box where we put all the tools. We have setup parts that we put in there. So we have an example of what a finished part looks like. It's clearly identified as a setup part so that it doesn't get mixed in with the production run. And, you know, it's just all of these things that help us get up and running faster. We keep a good eye on it. You know, it's very well organized. We have customer job boxes for, they're in alphabetical order. Their part numbers are in numerical order, and it's just one of those things that we focus on so that we can keep costs down. And it is a competitive bid thing, you know. It's not just reputation, but it's competitive. If there are 2 shops that can make the same part, and the reputations are the same, the track record is the same, the communication is the same, it comes down to cost and price. Track record, you know, it's who they're familiar with and cost. A lot of times you can get 5 or 10% more than another company that's just as good as you, just because you're a better salesman. Sometimes it doesn't matter how good a salesman you are, if the customer has a bad taste in their mouth because you screwed them over on something, you're going to have a hard time getting back. So those are some of the things that we look at when we're interacting with our customers.
For like an inventor who has never dealt with, you know, a shop before or a manufacturer, is there like 1 or 2 things that you would say that you kind of find that new inventors come in either not knowing or not really seeing, you know, is it like schematics, kind of schematics, or, you know, just kind of just 1 or 2 things that you find, you know, inventors come in and just don't realize that you would, you know, just recommend?
That we would what?
Just like 2 things of information that like if inventors just don't, that come in just not knowing that they need it.
My hearing is really poor.
Oh, okay. So, is there just two things, or, you know, just 1 or 2 things that you find that new inventors come into your shop just not knowing that they need to have?
Oh, I tell them what we're looking for. Yeah, I'll work with them. I'll tell them what we're looking for. And it's usually kind of a wake-up call for them. So I've had people come in with, high hopes of getting a product in a week or two and then go and market and having, money coming in within a month. So I'll give them just a quick rundown. The first thing I do is I say, do you have a patent? And if they say yes or no, we have to know that will determine which way to go. If they do have a patent, that means they've done an awful lot of work over it. If they don't have a patent, I tell them, listen, you better at least get some sort of protection on it, get an NDA or talk to a patent attorney. And then I walk them through as much of that as I can. And then, if they do all of that, and they come back with their product, they show it to me, I'll sign an NDA as long as it's very specific to their product. And they have to give me an idea of what the product is before they give me the NDA, what it relates to. Is it something about an automobile? Is it something about something that I may be working on? If it's something that I may be working on, I'm not gonna sign it. That's a pretty big deal there. I always say, you don't have to tell me how it works, you don't have to tell me exactly what it is, but I would like to know what it pertains to. So if I know what it is, and if it's like, a light fixture or something like that, I'll sign it. I'll sign it in. It's not a problem. As long as it's specifically directed toward what they're trying to develop. Okay. I don't want an all-encompassing thing that talks about how lights work, because I work with doctors. And that's something that was another patent story. We don't have time for that tonight.
Yeah. Right.
So, anything else? Okay, well, guys, thanks a lot. It's been fun. Do
you have cards?
Oh, yeah. Very good.